For this session, I would like to call our chair, Mr. Mohsen Munir. Mr. Mohsen Munir obtained his MSc degree in geology with specialization in structural and petroleum geology in 2003 and MPhil in geosciences from the University of Punjab. He then worked for Geological Survey of Pakistan and later joined Bahria University Department of Earth and Environmental Sciences. This is where he supervised and co-supervised more than 30 bachelor projects and MS thesis during his period. Mr. Mohsen joined OGDCL in 2010 and working as a senior reservoir geologist in Reservoir Management Department. Our co-chair for the evening is Mr. Sardar Awais Mukhtar. Mr. Sardar Awais is currently working as a petrophysicist in SLB and has a BS degree in geology from Bahria University. He also has an MSc degree in environmental sciences from ComSat's Aptabad. His career spans over 10 years of technical experience in the oil and gas industry with various national and multinational companies. He started as a geoscientist in 2013 with Park PetroServe Private Limited. After that, he joined Oil Indus Private Limited as reservoir petrophysicist. And lately, he joined Weatherford Pakistan as junior geologist before joining SLB in 2017. Everyone, please put your hands together for our chair and co-chair of the evening. Now let us begin with the first paper for our session 2. Micro-CT Reservoir Characterization, Unveiling Pore Scale Insights for Sustainable Hydrocarbon Recovery and Climate Change Mitigation by Mohammad Rehan Khan. There is one more thing I would like to announce. For this session, each student will have 10 minutes to present their paper. Once the bell rings, it means your 10 minutes are over to present, and then you may have 5 minutes for question answers. So in total, we have 15 minutes.
Hello everyone, myself Rehan Khan and I am from Punjab University, Lahore. Today the topic of my presentation is Micro-CT Reservoir Characterization, Unveiling Pore Scale Insight for Sustainable Hydrocarbon Recovery and Climate Change Mitigation. Here are the key headings of my presentation that include introduction, background, methodology, key findings, and the other strategies. Workflow is given here, which include fieldwork, sample selection and preparation, scanning setup, image acquisition, reconstruction, and in the end, modeling. So what is X-ray microtomography? X-ray microtomography is a technique that mainly used to visualize the 3D visualization of rocks or minerals. When we applied examination of rock sample of Micro-CT technology facilitate to give the image of 360 degree of angle. What is meant? It used the different slices of rock sample and put together to generate an image that is known as microtomogram. What is the background behind it? Microcomputed tomography plays a crucial role in reservoir characterization. We mainly concern two properties here. One is porosity and the other one is permeability. It provides pore scale insight when we applied Python module. What I did the query in it is the interpretation by using the Python module. Here is the map of my research area that mainly include the Poland or the Polish oil deposits. I want to add here something. I get the data by one of my LinkedIn colleague that provide me the microtomograph data, and I further proceeded by means of Jupyter Notebook in Python environment. What is the methodology behind it? Before methodology, I will discuss the main basin, that is the Ziastin main basin in the Lobato deposit that mainly comprise of dolomite formation. We process the data by using the Python module. Python module uses the different operation and algorithm and gives us the image. These are the microtomogram of sample 1 having the porosity near about 1.5%, sample B having the porosity 4.9%, and sample C having the porosity 22.1%. Mainly the formation is dolomite. Analysis of porosity by X-ray microtomography carried out the 3 samples of carbonate rocks, mainly dolomite formation. It also had the some amount of anhydrite and quartz. The porosity of the test method was calculated as the volume ratio pore, that is the conventional method and calculated by the early researcher. The porosity of test method was calculated as the volume ratio pore volume present in the sample to the total volume, that is the conventional method as I am talking about it. These are the method that was used by the early geophysicists. Sample A having the porosity about 1.5%, sample B having the porosity about 4.9%, and sample C having the porosity about 22.1%. In the below you can see the 3D diagram that is mainly showing the rock fragment and porosity. In green color in the first diagram of sample A, you can observe the porosity is very low. As you can see, there is no appearance of green color here. In the sample B, green color is present in some amount, that is showing the porosity about 4.9%, and in the sample C, porosity is about 22.1%, and this you can observe in the both picture, one in microtomogram and other the 3D picture that is given below. This was the first model that I designed using the Jupyter notebook, and it mainly uses the command or algorithm. Mainly what are the algorithm? A set of instruction that I provide to him. What is the identification of dolomite, what is the identification of anhydrite, and what is the identification of quartz. I give the pre-instruction to my model, and the model give me the result in the form of 3D scatter plot. As you can see in the 3D plot, that is color merging, and the 3D lithology bar chart that you can see here. About 88% of this area or this formation was consist of dolomite, and only 12% consist of anhydrite and quartz. This was the model made by using the Python programming. What mainly this explained to us? It mainly explained the distribution of pores in the 3D. Here you can observe the porosity or the distribution of pore. In the right side you can observe the heat map that is using the different algorithm to show the different values for porosity. Different algorithms are working here Gaussian etc. that are giving the different values for porosity. Some are giving the values 1.4, 1.5, and some are giving the values 1.6 that are very close to the value that was predicted by the early researcher. In the sample 2, same you can observe here 3D scatter plot. What is showing? It is showing the distribution of pores that are not connected here because it mainly deal with the porosity. And in the right hand side you can observe the heat map that is mainly showing the porosity in the form of precise value 4.8 to 4.9%, that is mainly very close to the actual value of 4.9%. And this is the same for the model 3. What are the key findings of my work? It includes the with integration of microcity data with Python module, we get result in the form of scatter plot. What are the scatter plots are depicting us? They are showing the actual distribution of pores in our 3D mechanism or 3D microtomogram. It is a theoretical or hypothetical model that is showing here using the actual values. After getting inside the pore, we measure the porosity by mean of Python that was very close to the actual value. What Python is actually using here? Python is actually using here the sum algorithm. As I already tell, algorithm is the set of instruction that I given to him how to calculate porosity, how to calculate permeability, how to calculate the either the formation is dolomite, anhydrite or quartz. And here are the some strategies that is mainly related to the climate change and mitigation that can be proved strongly. Microcity tomography can play a significant role both in climate change mitigation and enhancing hydrocarbon recovery by providing the valuable insight of the formations. By providing detailed information about the reservoir internal structure, microcity enable the identification of zone with the fluid flow. Where the porosity is high or the effective porosity is high, we can say this is the zone of interest for ourselves. In the same way, microcity helps in the designing more efficient production techniques which can lead to the reduced water and energy consumption. And in the conclusion, I will say, in particular investigation, I use the Jupyter notebook using the actual values of microtomogram and convert these values into the Python model that give me the 3D scatter plot and distribution of the porosity that can be used for the sustainable hydrocarbon recovery by estimating the our area of interest. These are the future direction. What in future we can do, we can also work with the permeability along with the porosity and draw the more result. Thank you very much.
We can take 2 questions, please. Can you identify by this methodology that this porosity you have calculated 22% as secondary porosity or the primary porosity?
It is mainly the secondary porosity because the area that I am mentioning, the Lubesto zone in Poland, it is mainly under the stress, so it is mainly the secondary porosity.
What kind of stress is there?
Force is mainly, that is mainly regional forces.
Regional forces?
जी.
Like compressional forces or
Compressional.
extensional forces?
Compressional forces mainly. Dolomites, dolomite.
Is there any other question, please?
Yes, sir, sure.
I have a question regarding your microcity data that technique you have used. What is the? Did you know the how to remove the contaminations of core during CT scanning? Did you use the core data as well in your data or not?
Yes, sir. This is mainly the core data that I use.
Okay.
3 samples. जी.
So you know that first of all we have to remove the impurities during coring, during conduct coring, like contaminations of mud. So you have catered these also contaminations in your project.
Sir, as I already mentioned, I get the data in the form of microtomogram that was pre-processed with the removal of noise mainly. That the data you're talking about mainly the contamination, and I only give the instruction to the my Python environment to work on it.
Okay, thank you.
Welcome, sir.
Thank you. Thank you, please. It's a nice presentation.
The next presentation is on identification and analogy of glaciogenic geometries between Punjab platform in Pakistan and proven glaciogenic play by Muhammad Hamad.
My name is Muhammad Ahmad from Department of Geology, University of Karachi. I am the presenter of the paper Identification and Analogy of Glaciogenic Geometries between Punjab platform in Pakistan and proven glaciogenic play. Aims and objective. Aims to identify the glaciogenic geometries, Permian glaciogenic geometries in Punjab platform, and assessment of Permian stratigraphic traps in Punjab platform. Contents. First we discuss the introduction of the Punjab platform, then permocarboniferous glaciation, then stratigraphy and geological model, data set interpretation, glaciogenic geometries analog, and conclusion and recommendation. Now, Punjab platform is situated in the eastern part of the Pakistan. It is bounded in the north by Grana Hills and in the south Jacob High in the east, Bikaner-Nagaur Basin, and in the west, it merges into the Suleiman Fault Belt. Punjab platform is actually a part of Bikaner-Nagaur Basin, in which you can clearly see that the north side Kirana Hills and south Jacob High. In the east, Bikaner-Nagaur Basin is present, and in the south, Suleiman Fault Belt. Introduction of the Punjab platform. This image is extracted from the Geology of Tectonics by I.B. Qadri. In this image, you can clearly see that this area is Punjab platform, and in this image, you can clearly see that the attitude of the bed present in the Punjab platform. Punjab platform is western dipping monocline because it has a significant distance from the collision zone, so it is relatively unaffected area. So there is a high chances to notable stratigraphic taps formed in the Punjab platform. Permo-Carboniferous glaciation. At the time of Permian and Carboniferous, the Indian plate was attached with Southern Arabian and Southern African plates. Permo-Carboniferous glaciation was started in the late Carboniferous and lasted and remained in the early Permian. It has lasted about 90 million years. Production of tealites and pattern in the pre-existing rock indicate the migration of glacier among the continents. In this picture, you can clearly see that the arrow indicate the migration of glacier among the different continents, which form the glacier, tealites, and other pattern on pre-existing rock. In the early Permian, when the warm temperature of Earth melt the glacier, it erode the pre-existing rock of Jhelum group and form new deposition of sediments. When glacier move, they erode the pre-existing rock and form tunnel valleys. These are the U-shaped tunnel valleys, which are geomorphic features. When glacier erode the pre-existing rock, they form the tunnel valleys and spurs. Stratigraphy and geological model. At the time of late Proterozoic, infracambrian succession was deposited. This is a geological model which showing the formation, first basement and then infracambrian succession. And in this stratigraphic model, you can see the basement rock, older rock, Jodhpur, Dara, Hansera, Nagpur, upper carbonate and salt unit were present, were deposited at infracambrian. In Paleozoic, Cambrian sediments, when the temperature was, when the sea level was rise and shallow marine environment becomes, the Paleozoic Cambrian sediments deposit and other further sediments and deposit Khevra, Khusak, Chitana and Bhagavanwala formations. This is the Cambrian formations. Now, the region was experienced a major unconformity due to the uplifting and other causes from late Cambrian to early Permian. After region experienced a massive unconformity, the glaciation later glaciation occurred in the early Permian when the temperature was increased or melt the glacier. The glacier eroded the pre-existing rock of Jhelum group, forming tunnel valleys and spurs. You can clearly see that when the glacier moved on the region, they eroded the Bhaganwala, Jutana and Kusak formation, and somewhere also Khevra formation, forming geomorphic features, tunnel valleys and spur. This is a representation of tunnel valleys when glacier eroded the pre-existing rock. The rocks were represented like this, forming tunnel valleys and spur. This picture indicates that the tunnel valleys and spur which is formed due to the movement of glacier. During Permian, ice sheet movement deposits pebble, gravel, and form topra formation. Sediment sources are from Malani and Aravalli range, which is situated in the Indian basin. When the sea level rises and the environment becomes shallow marine, they deposit other formations like Varcha, Dandot, and Sardai formations. Now, data set and interpretation. This is the Fort Abbas well schematic model from the Fort Abbas well, in which you can clearly see that the blue line top Paleocene and the green line indicating the top Cambrian and red line indicating the top base Tobra formation. Orange line indicate the top upper carbonate. This is the incised valley forming due to the movement of glacier, which form a tunnel valley and spurs. This is a picture. It was extracted from the Ibrahim Shah book, Stratigraphy and Geology of Pakistan. Map indicates that the Punjab platform. You can clearly see that here the Topra formation was cut the Bhagalwala, Jatana, and Nakusa formation, and somewhere also Fabra formation, forming tunnel valleys. Where it erodes, they form a tunnel valleys and onlapping and downlapping pattern of stratigraphic traps. In this picture, you can see that the Fort Abbas well schematic model, where incised valleys was formed due to the movement of glacier. They form a onlapping pattern against the pre-existing rock of Jhelum Group. Onlapping, and there also onlapping and downlapping pattern, which is good stratigraphic features. Down image was showing the which is the analog seismic line analog extracted from the glaciogenic reservoir and hydrocarbon system. This is indicating the importance of incised valleys. This image is indicating the importance of incised valleys, in which image you can see that the incised valleys, how incised valleys store the hydrocarbon. In this incised valley, tunnel valleys represent the hydrocarbon storage, and spur also store a hydrocarbon. This is the bottom and tunnel valleys in vertical section from the glaciogenic reservoir and hydrocarbon system. So just support the my research, in which this is the Fort Abbas well schematic model, in which I just let you see that there is a incised valley formed due to the formation of movement of glacier, and onlapping and downlapping pattern was produced. Conclusion: glaciogenic geometries have been identified in the Punjab platform. These geometries include tunnel valleys and spur. These geometries are considered to be the stratigraphic traps in the Middle Indus basin. As we know that the Tobra formation was conglomerate and a good porosity and permeability. The Adi and Damal wells are also hydrocarbon producing from this well, from this formation. Based on recommendation is that based on available seismic data, the presence of tunnel valleys could be marked, and high resolution 2D seismic data can also validate for more possible tunnel valleys in the region, and prepare a tunnel valley distribution map. And high resolution 3D seismic data can also validate and also help to see the real extent of the hydrocarbon in the tunnel valleys, and for further investigation. Thank you.
Thank you, Rehan. Now the floor is open for question answer session.
ये लीजिए.
My question is this, in tunnel valleys, you have said that there is a possibility of hydrocarbons. So you have not defined the petroleum system of the sediments deposited in that valley.
I just, my paper topic was just to identify the glaciogenic geometries forming due to the movement of glacier. I just recall this, and when onlapping and downlapping pattern was produced, this is the stratigraphic traps, forming a stratigraphic traps. तो देर हमें अगर हम इसके ऊपर और ना रिसर्च करें, इसकी और ना सेस्मिक डेटा के ऊपर इंटरप्रिटेशन करें सही से, तो हमें और पता चल सकता है कि
आपने उसमें बताया ना कि हाइड्रोकार्बन हैं, तो उसके लिए जाहिर है कि यू हैव टू डिफाइन व्हाट इज द सोर्स रॉक एंड दैट वैली एंड व्हाट इज द रिजर्वायर रॉक एंड अदर
बिल्कुल पॉसिबिलिटीज़ हैं, क्योंकि मेरी सिर्फ ये थी कि हमने आइडेंटिफिकेशन करनी थी ग्लेशियरिक ज्योमेट्रीज की कि ये चीज़ें बनी हैं पंजाब प्लेटफॉर्म के अंदर.
And you named this Bikaner Nagur basin, and basically this basin is related to the infra-Cambrian sediments, and there are heavy oil discoveries in India, and these are all related to the infra-Cambrian sediments, not to the valley deposits.
नहीं, जैसे कि आप जानते हैं कि जब ग्लेशियर ने इरोड किया था,
नहीं वो मैंने सारा एग्री कर लिया,
तो जो सेडिमेंट सोर्स की जो सेडिमेंट्स थी वो अरावली रेंज और मलानी रेंज ही थी. तो जो उन्होंने तोबरा फॉर्मेशन हमारे पास डिपॉजिट हुई, तो बेसिकली मैं ये नहीं कह रहा कि उसके अंदर है तो उसके अंदर भी होगा.
आई थिंक देयर इज अ नीड टू have more work related to this paper, and also identified the basement grabens, like you have shown the valleys. There are basement grabens in this area where the infra-Cambrian sediments may be deposited, and they have their own petroleum system like that valley, and there will be a potential for hydrocarbon as well there.
Sir, okay. Thank you.
Any other question? Okay. Thank you.
Thank you.
The next presentation is on geothermal gradient and borehole temperature analysis of different oil and gas fields of central and southern Indus Basin by Muhammad Afzal Jamali.
So start in the great name of Almighty Allah, who is the most merciful and most beneficent. This is Ali Imran Bhatti. I am final year student of geology, and I am a presenter of this paper. So today's my presentation topic is geothermal gradient and borehole temperature analysis of different oil and gas fields of central and southern Indus Basin. As a geologist, as you all know that the Indus Basin is a part of Indian plate. It is located in the northwestern part of Indian plate. So the Indus Basin is divided into two main parts, upper Indus Basin and lower Indus Basin, and in lower Indus Basin we have two parts, just like central and southern Indus Basin. Here we have a table of contents, just like introduction, methodology, results and discussion, and conclusion and references. So geothermal gradient. So it can be defined as increase in temperature with respect to increasing in depth inside the earth. And geothermal energy is the subsurface heat energy. The sources of this subsurface heat energy is internal source as well as external source. So the internal source, we have two main factors, just like we have a radiogenic heat that has going to be generated by the radioactive decay of some isotopes, and the number second is the primordial heat that was entrapped in our earth planet during the formation of our planet, and the external source is sun. So based on the present increasing trends of world population and energy demand, it is expected that the conventional sources for the energy generation will be exhausted by the end of this century, Jamali et al. 2022. And an unconventional source of energy, just like geothermal energy, is a cleaner and environment-friendly source of energy, which gets importance as an alternate to the hydrocarbons, Gupta and Roy 2007. And the Indus Basin has a potential to generate more than 40,000 megawatts of energy and heat. So the aims and objectives of our work, based on the borehole temperature data, identifying the variation in the temperature with depth, and the determination of locations of anomalous zones for the geothermal gradients, evaluation of geothermal energy of central and southern Indus Basin, especially in the regions like Sui, Kantkot, Maribukti and surrounding wells, wells by using the geothermal gradient data and borehole temperature data, and analyze the potential of study area according to geothermal energy generation, considering for both electricity production, direct heat use, and for the from the abundant oil and gas wells in the studied area. Here we have a location map of our study area that is showing the location of 57 different oil and gas fields of Sui, Maribukti, and Marikonkote and surrounding wells and in southern Indus Basin. Here we have another map of our study area. This is the figure number 2, showing the position of 57 different oil and gas fields in the different tectonic domains. Just like if you see in the upper side, we have a Maribukti and Sui area. In the central area, we have a southern, and in the eastern side, we have a Marikonkote. So we have a methodology. Geothermal gradient data of different oil and gas wells of central and southern Indus Basin were obtained to calculate and analyze the subsurface borehole temperature and geothermal gradient. The borehole temperature of 57 wells of Sui, Maribukti, Kantkot, and I was plotted against the depth using different software sites such as ArcMap 10.8.2, Google Earth, and satellite images, and the Surfer 8. And using the temperature data, contour and different special maps was prepared. The geothermal map, gradient map was also generated. Here we have results and discussion. This is the table number 1 that is showing the different wells name according to the geothermal gradient per 100 meters. And here we have a table number 2 that is showing the wells number, total depth, BHT temperature, DST temperature of 57 oil and gas fields. So this is the figure number 3 that is showing the isothermal geogradient anomaly map of southern Indus Basin. And if you see here the distribution of geothermal gradient anomalies in the eastern folded west thrust also demonstrated association with the geological trends. If you will see there, we have a geothermal gradient of 2, then we have a 2.5, 3, 3.5. In that order, we have a 4.5. So the Gandhario oil and gas wells in this region encountered an abnormally high geothermal gradient of 4.1 per 100 meter, 1986, Khan and Raza. So similar to this, Sui and Mari in the south and southeast displays the typical geothermal gradient between 3 and 3.49 degrees centigrade per 100 meter. So this is the geothermal gradient map of southern Indus Basin. If you will see here, we have a Tata, we have a 3.5, and in Hyderabad region we have a 3 and 3.5. Then we will, if we will move towards the Nawabshah, there we have a 3.5, and upwards the Nawabshah. Further move towards the south, we have a 4 and 4.5. So this is the BHT analysis of our study area. Just like from the above given data, it has been concluded that the neighbors, well number 22, 21, they are going to having a great BHT temperature as compared to their surrounding wells. And if you will look at the map, we have a temperature table and we have colors. So the dark red color marks the BHT of 59 to 70, while if you will see the green color, it marks the 152 to 164 BHT temperature. So the borehole temperature data of in the deep wells that is drilled at the average of 3,500 meters at the Sui and Maribukti areas have a high BHT, just like 4.4 degree centigrade per 100 meters, while the shallow depth wells are 1,400 meters deep, that having a temperature of average about 65 degrees centigrade. So this is the DST temperature map of our study area. The map showing the variation in the DST temperature, well number 1, well 20, well 21, and well 35, that having abnormally high DST temperature. So these well has the DST temperatures that are relatively higher as compared to the rest of the DST values. So this is the geothermal gradient map of our study area that is showing the geothermal gradient. If you see here the light orange color, here we have a geothermal gradient of 4.4 to 4.2, and if you will see the red color, here we have a 4.2 to 4.3, while the light green color, it shows the geothermal gradient of 4.3 to 4.4, while the if you'll see the dark green blue color, that is showing the geothermal gradient of 4.5 to 4.6. So the conclusion is the study area shows high geothermal gradient at Sui and Maribukti and Concord and surrounding wells in the central and southern Indus basin. That is approximately 4.5 geothermal gradient, and borehole temperature is also high in that areas. So the study reveals that this area has a great potential to generate the geothermal energy in the study area. The surface geological setting and deep-seated basement tectonic setting of the study area reflect brilliant hope for the development of geothermal energy resource, just like energy generation or direct heat use. These are the references, and thank you very much. And now the room for the question and answers, suggestions and recommendations is open for everyone.
Okay. We can take 2 questions from the audience, please. आपने इसमें स्टडी में एक तो BHT यूज किया है, दूसरा DST यूज
Yes,
किया
sir.
है। BHT is the bottom hole temperature and DST is
Release
the temperature during DST from the reservoir. Okay? तो आपने इससे जो टेम्परेचर कंक्लूड दोनों से कंक्लूड किया उसका कंपैरिजन किया, क्योंकि ये जरूरी नहीं है कि बॉटम होल जो है वही DST का लेवल हो।
नहीं, वो इसमें देखें ना आप, as I have mentioned here that well number 1, well 20, well 21 and well 35 has a great DST as compared to their BHT. There is a little bit variation between DST and BHT. If you look at this map, and here I have mentioned only well 22 and well 21 that has a great potential for the BHT temperatures.
और जो आपने जियोथर्मल ग्रेडियंट निकाला 4
geothermal gradient actually that was calculated from the BHT temperature.
BHT टेम्परेचर,
Yes.
ठीक है। और उसका आपने जो ग्रेडियंट है पर 100 मीटर रखा है?
Yes, per 100 meters. Per 100 meter, as I have already mentioned it.
4.1 per 100. जी, क्वेश्चन कोई और हो अगर ऑडियंस में से?
Yes, sir.
DST and BHT. So it's good if you use a graph that shows the variation or difference between both temperatures.
Yes, sir. Right.
So it's my suggestion.
Thank you, sir.
Okay.
I will add it. Thank you very much.
Thank you, brother.
Thank you.
That's great work. I like it.
The next presentation is on prediction and analysis of geomechanical properties of Sambar shale in the lower Indus Basin using deep neural network by Abdullah Ibrahim.
Assalamu alaikum. This is Abdullah Ibrahim from University of the Punjab, Lahore. Today I am here to present the topic prediction and analysis of geomechanical properties of Sambar shale using deep neural network. Starting from the introduction. In recent years, there has been notable global rise in the search for and production of unconventional resources. To efficiently produce from unconventional reservoirs, it is imperative to determine and understand the geomechanical properties of the unconventional reservoir. But due to the complexities, heterogeneity, and missing borehole information, shale formation faces challenges in accurately estimating the elastic properties, which triggers severe technical challenges in safe drilling and completion. This leads to the idea behind this study. So a predictive modeling is performed by supervised machine learning utilizing artificial neural network. The target study area is Khewadi, lies in the lower Indus Basin, a geologically complex area bounded to the north by Sucker Rift and confined by vast Kither fold belt. It is interpreted as extensional area developing as a consequence of divergence of Indian plate from Gondwana beginning in the late Jurassic. Mainly the host and graben structures are present, including Cretaceous and older strata. And the stratigraphic sequence of the lower Indus Basin covers the lithostratigraphic units from Triassic to recent. The target formation of the study is Cimber formation as highlighted in the red box in the stratigraphic chart. It is predominantly shale with intercalations of sand, and it is well known for its unconventional potential and as major prospects to contain generous amount of shale gas in the lower Indus Basin, Pakistan. A methodology was developed for the prediction of missing borehole information and then the estimation of geomechanical properties. It includes acquiring well data from lower Indus Basin, then after processing the analyzed data split it into the training data sets and testing data sets. Then the model was trained using training data sets and evaluated through testing data sets. After validation of the model, it will be used for the prediction of missing borehole information and then for the estimation of geomechanical properties. And on the left side, the model used in this study was ANN artificial neural network utilizing LSTM, and its architecture was shown on the left side bottom. It is a network of connected neurons in which each layer processes data and pass forward to the next layer, with the last layer making decisions. And the input features of this model are the raw logs. During data analysis, the outlier detection is crucial because they can distort the overall picture of the data and it can mislead the conclusions if not properly handled. So during the initial inspection of the raw, all the outliers were removed manually from the well data using interquartile range. A block spot as shown in the figure is used to identify presence of outliers in well X1. We consider the data points shown in reds that fall below the lower whisker and above the above whisker as outliers. This same process was adopted from the data of well X2 and X3. This is the log curve display from the well X1 in which gamma ray density log and DTS and DTP are given, and on the right side there are two more logs. The first one is the Young modulus and the second one is the Poisson ratio. These two elastic properties are calculated from the given raw logs by using their formulas. And this is also the this is further the log curve display from the data of well X1 from which the elastic modulus and Poisson ratio are calculated. This is simple because we have all the information of the parameters that are required to calculate the these two elastic properties. And when we talk about the correlation coefficient, the heat maps of correlation of well X1 as shown in figure, it is a statistical technique which show how each feature is correlated with other well parameters. And from the correlation matrix we can conclude that the both DT and gamma ray has high relative significance in estimating rock strength. And this is the visualization of log data from well 3, and here on the right side you can see the density log has portions of missing information, and due to this we were not able to accurately predict the elastic properties which can lead to incorrect conclusions. And so the machine learning model will work here to predict these missing information from the welder. And when we talk about the correlation matrix of well X3, here we can see the DTS showing highest relative significance among other well parameters. It is useful technique for building regression models. Therefore, accurate prediction based on ANN model is developed that is capable of predicting missing or incomplete borehole information. The well X2 and X3 are selected for training, and then the model predicted values are validated by the original DTS values of well X1. to serve as a blind validation. The original DTS values from the well X1 have been eliminated, and the contrast on the right side shows a great match between the predicted and the actual values, with the R square valued of 0.97, which shows that the model is giving the 97% accuracy. Then I applied the algorithm on well X3, in which the density log has missing information, and we can say that the beauty of the machine learning model here is that it will work in the backend to fill the missing information of the model, and then after validation and based on prediction, new prediction results, it will directly gives us the values of elastic Young modulus and Poisson ratio with these two key elastic properties. As we all know, the geomechanical properties plays an important role in various stages of upstream, such as locating sweet spots for fracturing and wellbore stability. So the ANN model is developed that will be used for the prediction of missing borehole information and then estimation of geomechanical properties. And this is outcome, and your outcome shows the astonishing capability of artificial intelligence. Operators could leverage these tools to examine the fracture interpretation with reduced cost and time, and to maximize the hydrocarbon recovery potential.
जी थैंक यू जी कोई क्वेश्चन अगर हो तो Any question, please, from the audience?
Yes, I have a question regarding
Okay.
about the sample formation. What is the minimum and maximum range of the Poisson ratio you have estimated? And secondly, what is the minimum and maximum range of Young's modulus?
Sir, basically the topic here, the concept of this topic here is to just only the estimation of geomechanical properties. Then to evaluate this geomechanical properties to predict reservoir information, it will be the next step. And
No, you already have shown the curves of Poisson ratio and Young's modulus.
Yes, sir.
I think you should know the values, minimum and maximum values of Poisson ratio and Young's modulus. You already predicted from sonic log data, right?
Yes, sir. Yes, sir. It is estimated through machine learning model, and it is given by the machine learning model, and it will giving this 97% accuracy. And the evaluation of these geomechanical properties will be the next step. Only here it is giving just the estimation of geomechanical properties with 97% accuracy.
Okay, thank you.
Thank you.
ये स्लाइड पे जाइएगा जरा जहाँ पे आपने वो मिसिंग डाटा डेंसिटी लॉग का दिखाया था
जी सर. Yes, sir.
अच्छा जो आपका टॉपिक है उसके मुताबिक जो हमें समझ आई है वो ये आई है कि आप एक मशीन लर्निंग के थ्रू न्यूट्रल नेटवर्क के थ्रू आप ये जो मिसिंग डाटा है इसको प्रिडिक्ट करेंगे पहले
जी सर.
और इसके अगेंस्ट आप जो है वो यंग्स मॉडुलस और बाकी सारी मैकेनिकल प्रॉपर्टीज जो वो कंप्यूट कर रहे हैं.
नहीं सर, मिसिंग बोरहोल डाटा इट विल बी
ये मिसिंग बोरहोल डाटा आप पहले कंप्यूट करेंगे अपने वो उस प्रोसेस
Yes,
के
sir.
थ्रू जिसको आपने फिर बाद में अगली स्लाइड्स पे कहा कि बैक एंड पर वो काम कर रहा है और हमें डायरेक्टली जो है वो यंग्स मॉडुलस की वैल्यू दे रहा है.
यस सर.
तो आया इसको कौन वैलिडेट करेगा कि जो उसने पीछे कैलकुलेट किया है वो एक्चुअल इसके साथ
हाँ
वैलिडेशन में है.
सर, ये जो नेक्स्ट स्लाइड जो हमने एल्गोरिदम की अपनी टेस्टिंग की है कि वेदर इट इज़ अंडरस्टैंडिंग द फीचर्स और नोट, इट इज़ टेस्टेड ऑन व्हेन द DTS वैल्यू, इस पे हमने टेस्ट किया है और ये हमें 97% एक्यूरेसी दे रहे हैं, जिसकी वजह से हम
वेल के ऊपर किया है.
अननोन वेल था. This is unknown well to model. This is unknown well to model. And we for validation we applied the algorithm on the well X1 and the contrast shows you can see.
तो इसमें जो ये ब्लैक है ये ऑलरेडी अवेलेबल डाटा है और रेड वाला जो है आपने प्रेडिक्ट
ये
किया
yes
और
sir,
इसको मैच कर लिया।
yes sir, comparison,
इस
this is
मैचिंग का जो एल्गोरिदम है वही आप उसके ऊपर अप्लाई कर रहे हैं।
parameters different because we don't have the full information of density log in well x3, so we have to test our algorithm whether it is understanding the features or not. So we tested the algorithm on one of its feature that we are using for the prediction of density log. So this is the testing of the algorithm, and then we will use, because it's giving 97% accuracy, so there
अच्छा, मैंने ये क्वेश्चन आपसे इसलिए पूछा है कि डेंसिटी लॉग जिन प्रॉपर्टीज पर बेस करता है वो प्रॉपर्टीज एक ही एरिया में डिफरेंट वेल्स में डिफरेंट हो सकती हैं। तो अगर आप एक वेल के ऊपर वैलिडेट करके उसी चीज को उधर अप्लाई करेंगे और उसको वैलिडेट नहीं करेंगे डेंसिटी को किसी और पैरामीटर के साथ, चाहे किसी और लॉग के साथ मैच नहीं करेंगे, तो आप जो वहां से यंग्स मॉडुलस और बाकी चीजें जो कैलकुलेट कर रहे हैं उनकी भी ऑथेंटिसिटी इतनी बेहतर नहीं होगी उस वेल के लिए जिसके लिए आप वो काम कर रहे हैं, जहां में मिसिंग बोरहोल डाटा है।
जो
ये प्रोसीजर वाइज ठीक है, आपने काम किया, प्रोसीजरली दिस विल बी डन, लेकिन ये है कि उसकी वैलिडेशन के लिए कोई और मेथोडोलॉजी
सर बेसिकली टोटल 3 वेल्स यूज हुए हैं ना, जिसमें से हमने दो यूज़ किए एज अ ट्रेनिंग, और जो मशीन लर्निंग का प्रोसेस है उसमें यही है कि हम 2 वेल्स को एक चीज़ को ट्रेन करें फिर उसको हम अप्लाई करें दूसरे। इसमें पैरामीटर्स वी हैव टू डिसाइड बाय आवरसेल्व्स, ओके, एंड देन वी विल ट्राई। थैंक यू सर।
Now we will have the last presentation for this session, Assessment of Hydrocarbon Potential of Salt Range Formation by Mohammad Mahad Arif.
Assalamu alaikum, this is Mohammad Mahad Arif from Department of Geology, University of Karachi. The topic which I would like to present in front of you is the assessment of hydrocarbon potential of salt range, Pakistan. So salt range formation, which is situated in the north of Punjab, along the, in the south of Potwar Plateau, extended along the river Jhelum in the north. So in this presentation, in my research work, I am working on Cossack formation of salt range formation, which I refer it as oil shale. This is the lithostratigraphic chart of salt range formation. In this chart, I would like to show you that the Cossack formation is of early Cambrian age, lies above the Khebra formation and underlain by unconformity. So the best quality occurs within the topmost of salt range topmost of the formation in the eastern salt range. This is about the Cossack formation, in which is containing the 30% of total organic carbon. This 30% TOC is inclusive of all carbonate carbon, means it is containing all type of impurities, and this is the surface sample. That's why it is containing high amount of TOC. So the objective of my work is to evaluate the source rock characteristic of salt range of Cossack formation and to evaluate the geochemical parameters for petroleum exploration. What are the research gaps which I would cover in my study? Analysis of isotopes of source rocks of Cossack shale, and I have tested my sample from advanced analytical techniques, which I will show you in further slides, and diagenesis and thermal maturation impact studying, and investigating organic and inorganic rock interaction. So these are the research gap. I have classified my sample into 2, high grade oil shale and in low grade oil shale sample. This is a map of salt range formation, where the outcrop shows already already these are the outcrop from which samples are collected. We have collected our sample from Khevra Gorge of Kosak Shale, and these are the wells data which are already drilled, and I am collating my data of Khevra Gorge Kosak Shale from 2 wells. Which procedure I have used? I have used a LICO carbon analyzer machine for the estimation of TOC. Pyrolysis data was carried out isothermally at 600 centigrade using a Shimadzu GC9A pyrolyzer and a rock evaluation 2 instrument. So this graph shows our sample of Khevra Gorge lies in the early oil maturity phase on this part maybe. So it will be the early oil maturity phase with vitrinite reflectance of 1%. For extractable organic matter, we have heated our sample for 15 hours and use dichloromethane, which is a organic solution for the fractionation of EOM into saturation hydrocarbon. We have used gas chromatography and liquid chromatography techniques. For the gravimetric determination of our Kosak shale sample, we have used a Perking Elmer gas chromatograph machine. And for the biological marker machine, it is still in progress, but we need Finnegan Met in course 50 for the analysis of biological markers. So stable isotope analysis, which I have discussed in my research gap, I have done this testing through stable isotope analysis from BGR Germany. What are the research findings? Only I have the data of Khevra Gorge of Kosak shale, and these are all the reference ranges of my data. And another one, these are the coal sample from which I am correlating my data of Khevra Gorge and wells data. So in Khevra Gorge of Kosak shale, we have estimated the total organic carbon of 1.58 to 36%. It contains all type of impurities because it was a surface sample, so that's why the TOC content was too much high. Pyrolysis data, pyrolysis range was between 6.62 to 278 kilogram per ton, and the sample of Kosak shale lies in the type 1 maturity at 900 hydrogen index. Extractable organic matter, sample of salt range formation were collected for bitumen extraction. The ranges of TOC, EOM and TOC ratio was 24.4% when we have divided EOM with TOC for the ratio. So the extractable organic matter was 24.4%. The conclusion, which displays substantial hydrocarbon source rock potential. The primary organic component are bitumen and solid bitumen with significant leptinite. In the western salt range, this is the reference data, and this is the reference data of wells, Dalmial and Dharyala wells. So our data is of eastern salt range, which is estimated 30% of TOC with hydrogen index of 879 milligram per kg, and EOM TOC ratio was 24.4%. Thank you. The floor is open for questions.
Thank you, Mahad. Floor is open for the question answer.
Good paper. You have used 2 wells Dhariyala
as a reference.
and how did you get the sample and where you have? How do you find the sample? Because Dhariyala one was drilled back in about 50 or 60 years ago.
No, sir, we haven't collected the sample. Just these are the reference ranges from which I have correlate my data of Khebra Gorge. We haven't collected the sample from these two wells.
Oh, but what about the other samples? I think in the first of your slide you have showed that there are about 9 or 12 locations from where you have collected the sample.
Only for this study, I am just targeted on the Kusak formation of Khebra Gorge.
Kusak formation?
Kusak formation, shale.
No, but you're talking about the salt range.
Salt range.
No, Kusak formation or salt range formation?
Kusak formation of salt range. Salt range area, it's not a formation basically. Kusak shale. Yes.
Assessment of hydrocarbon potential of salt range formation in Pakistan.
No, it's not a formation.
क्लैरिटी नहीं है कि हम salt range formation की
No.
बात कर रहे हैं कसर की
Salt range for
मार्क्स अपने दिए हैं उसमें भी आपने salt range का जिक्र किया salt range formation का
salt range formation, salt range area. This is an error of formation, but we are talking about the area. Salt range area in Kusak formation of salt range. Sorry?
The samples are from Kusak formation.
Yes.
Right. So it means salt range area, Kusak formation.
Kusak formation.
Okay, it's fine.
G outcrop.
And
Yes.
rest you are using as a reference from the published data.
Yes, I am using the reference from published data.
And the sample which you have collected from the Kusak,
Kusak.
that was the actual data you have
Yes,
collected
yes.
yourself.
That's all
All
the
right.
actual data.
Okay, any other questions? Thank you.
With this, we conclude our session 2 for the GNG student paper contest. To distribute a token of gratitude and souvenirs, I would like to call upon Mr. Tahir Maqsood and Mr. Maaz Siddiqui to please distribute the souvenir to our chair and co-chair. Sir, please.
सर एक
We will now distribute the certificates to the students for the second session. Sir Mohsin, if you could please come on stage to distribute the certificates. Mohammad Rehan Khan. Rehan. Mohammad Hamad. Mohammad Afzal Jamali. Sir Uwais, if you would please come on the stage for the certificates. Abdullah Ibrahim. Mohammad Mahad Arif.
लास्ट पे वो अरे वो जो मास वाला था ना,
कौन है मास?
4 वाला देखो, 4 वाला फर्स्ट सेशन का 4
मास शहजादा आलम. I would like to thank our chair and co-chairs for the sessions today. I would also like to thank our teachers and students for participating. This is for all the students, all the advices and guidances which were given to you during these sessions. Please take these back home to your universities and always keep striving for a better tomorrow. This is your learning stage. And this is already a big achievement that you all came here to present your findings and papers. Inshallah, next year we will have even more and much better papers from you all. The results will be announced in the main hall at 4 p.m. May the best paper win.
और काइंडली अब सारे जितने भी है वो मेन हॉल में चले जाए, जिधर प्रोफेशनल का हो रहा था ना, उधर ही सबकी वो पोजीशन भी अनाउंस होंगी और सबको शील्ड्स भी डिस्ट्रीब्यूट होंगे.